to have more than 1 kilo. So you cannot have this at a payload in a drone, not a small drone. You have to have a really big drone to can carry this payload. And more than that, the energy consumption of this solution is really big. I'm talking about when you have a drone, the energy of the battery is about 16 kilowatt hours. So just the sensors can consume that. It's really not very efficient. He use this kind of solutions. So after that, I will present the. After that, you finish the problem definition. So with the problem definition finished, you can start to talk about the proposed solution. So the proposed solution works by using a drone, a single array, and a computer to make the SLAM, the 3D mapping in the location. The SLAM is the location of the system. So to do that, we have many. First, build the array. To do that, you have to determine a group of variables. That is mainly the frequency. That is the motor emitting the sound, and see how the noise interfering in these captures. So to do that, we use an oscilloscope to determine the frequency. First, we use the drone without propellers, just to make the test of what house of frequency they are emitting sounds. And with no propellers, it's a lot of noise, but they start on the frequency of with low velocity of the motors. You have this case when you have a lot of frequency concentrated in the case of 7.6, but when you spin the motors a little faster, you can start appear components on the average frequency between 16 and 17 hertz. So we know right now that you can spin between 7 and 18 kilohertz the sound, and we put the propellers to really satisfy this, validate this solution. With the problem, we see that the noise start not to be a lot of presence. When you spin the propellers, with the propellers, the sound really increases. And you can start to see, mainly when the motor is spinning really fast, the location of the frequency that it's present in. Here you see a presence in 8 kilohertz. Here is the case of 15 to 16 kilohertz. So with these parameters, we define that the boundary that we will use is between 7 and 15 kilohertz. The max frequency to filter is 15 kilohertz, and the distance between the sensors must be 2 centimeters. So with that, we will start to build our array. That's the finished product. To build this array, just the array. After that, we use a board to capture the signal emitted by these sensors. The board is just Arduino Mega, Arduino Nano. So in the theory, you can capture about 2,500,000 samples per second. On the real world, you just